to another topic in our environmental sciences class. Let's talk about global freshwater resources. This is going to be the part one of that lecture topic. So first take a look at the global distribution of aquatic resources. About 97%, in fact slightly over that much, is covered by oceans. So like a greater proportion of global water supply is salt water. So the freshwater extent, or the extent of freshwater, is less than 3%. So out of that, right, about 80% are not available biologically immediately, because about 80% is trapped or exists in form of ice caps, ice sheets, glaciers, snow. Um, so in solid forms that are not immediately or readily available for biological demands. Um, Now the rest of the or 20% is actually going to be well, there's another 20% plus left, that are not trapped in ice slash snow slash glaciers. But out of that, about 20% is actually going to be in form of groundwater, right? So that too is not readily available, right? So about 1% is actually available as fresh water that occur in surface water and that are readily available, or like somewhat available to satisfy biological demands. So out of that 1%, about 52% occurs as lake water. About 38% exists in form of soil water, and then another fraction as water vapor in the atmosphere, and then again another fraction as tiny fraction as organismal water, meaning water existing at cellular or subcellular level or tissue histological level within organisms, right? Another fraction in rivers. So overall, only 0.024% of global water budget is available on the surface of the earth, which can be supplied to satisfy biological demands. So naturally, freshwater is a very rare yet extremely critical biological resource. So this graphic sheds a very interesting perspective to understand how rare global water or the freshwater is as a biological resource. So here we are going to actually describe that by looking into the overall size of the planet Earth, and then kind of trying to equate the size of the Earth into like literally creating a hydrosphere by putting all the different types of water resources together. So the Earth is nearly 8,000 miles in diameter, slightly less than that, but about 7,918 miles in diameter. Now, if you put all forms of water, into a sphere, that would be about 860 miles in diameter. If you put all liquid form fresh water, right, in swamps, lakes, groundwater, and river into a sphere, that would be about 170 miles in diameter. If you just take fresh water that are available on the surface from lakes and rivers that are the most readily available of biological water, that's actually going to be a sphere that is not larger than a tiny dot, which is about 34.9 miles in diameter. Distribution of precipitation across the planet Earth is uneven. First, you can see there are lots of there are areas that appear in yellow color: the Saharan belt, the Saharan area, the entire, almost the entire Arabian Peninsula, parts of Western United States, the entire northernmost parts of both North American and Eurasian continents, huge portion of Central Australia, um, and parts of Central Asia do not receive much precipitation. And now, where do you see high levels of precipitation? Well, that is the tropical belt. The sub-equatorial and sub-equatorial areas receive very high level of precipitation. To name a few, we are looking at Congo Basin, Amazon Basin, um, parts of the Panamanian region that connects North and Southern Americas, um, Central and Southern Pacific islands, certain parts of Indian Ocean, the Indian subcontinent receive very high level of precipitation, and also Western Africa too receives very high level of precipitation. Now, secondary to that, we can talk about Pacific Northwest, that includes Washington, Oregon, and parts of Alaska and parts of British Columbia. Now, that's within the temperate rainforest area, do receive significant levels of precipitation. That also includes both rainfall and snowfall. Um, well, there's a little bit of rain spots in parts of Western Europe, particularly some of the British Isles receive very high level of precipitation, and then parts of Southern Australia and New Zealand also receive significant level of precipitation. And that the last one, that is actually part of Southern United States, that's particularly in and around the Gulf of Mexico, also receives relatively high level of precipitation, but that precipitation could be fairly seasonal. And some areas, particularly the equatorial area, the precipitation is aseasonal, but other areas like the Pacific Northwest, Western Europe, and the Southern United States, precipitation could be seasonal. So even areas that receives very high level of precipitation may either receive that seasonally or aseasonally. Now, this animation shows the average monthly precipitation across the world in the year 2009 and how that actually varies across different months. So kind of showing seasonality of precipitation in the year 2009 at global scale. Um, Now, if you are interested in looking into these kind of animations regarding precipitation seasonality, I encourage you to check the link up over there, and actually you can also observe the seasonality of precipitation for the years over there as well. So you do clearly see that certain parts of the planet Earth, the Saharan areas, Africa, the Arabian Peninsula, right, certain parts of Central Asia, and parts of Australia remains, receives extremely low level of precipitation, right, even across the year, right. And again, you see certain parts like the Amazon Basin, the Central Africa, um, a huge part of southern and southeastern Asia receives very high level of precipitation year round. And again, you can see the very thin belt in the northern part of the western North America also remains extremely relatively high in terms of precipitation. So again, this is kind of driving the point I earlier mentioned that I mentioned earlier. Um, Certain areas of the planet receives precipitation aseasonally. Certain areas receives high precipitation seasonally. And other areas remain extremely dry throughout the year, right? And in certain parts, if you look at parts of southwestern Africa, right, that remains relatively dry quite a lot. It's a very biodiversity rich region, but you can see precipitation is extremely seasonal, right? Maybe limited to a month. In fact, truly speaking, the rainfall in this kind of the southern Africa, right, southernmost Africa, is going to be limited to, like, it's for most of the areas no more than a couple of weeks, right, and sometimes maybe a month at most. So it's quite interesting to see these variations of rainfall patterns. And if you look at the Indian subcontinent, you will notice that there is a very high rainfall strip occurring in the westernmost area around the month of June, July, and August. Now that's actually the Western Ghats, extremely high in biodiversity, and that's actually a very diversity rich um, critical ecoregion in the world, the Western Ghats. And you can see the island of Sri Lanka also appears dark blue, like as a high rainfall area in certain parts of the year, which corresponds to two different monsoons. Um, so yeah, I mean, you can actually go on and kind of start questioning yourself. What kind of ecoregions do you find in high biodiversity regions, right? And also, you can see the same pattern in Madagascar too, right? In certain times of the year, early in the year, you can see most of the island receives very high levels of precipitation, and in other times, it actually remains relatively dry. Even in South America, you can see those desert areas, kind of located inside the mountains, and the Andean mountains also remain relatively dry for the most of the year. Why rainfall slash precipitation is uneven across the planet? There are many reasons for that. The number one is the different ways global atmospheric circulations happen across the world. That actually follows somewhat of a latitudinal gradient. This kind of goes back to your lectures in ecology. So I'm not going to go into that much detail because I expect you to know these things already. If you don't, you have to refer back to your notes from ecology. So starting from the equator, right? Warm air currents rises up, right? And those warm air currents carries moisture with them. And then those warm air currents moves northward and southward, carrying those, and these air currents also carry this moisture, right? And then as they move towards higher latitudes, particularly around areas of Tropic of Cancer and Tropic of Capricorn, those warm air currents form clouds, and those clouds, start to precipitate back towards the equatorial region, right? I mean, so that's actually primarily why the equatorial area gets so much precipitation. And also, there's a movement of air currents that brings in more moisture from the polar region um, towards the equatorial area. So if you think about that, when air pockets descend, it kind of creates some sort of a vacuum. So that vacuum should be filled up by something. So the movement of air pockets from the polar regions kind of carries more moisture, right, into the equatorial area. So and that again provides more precipitation to the equatorial area, right? And kind of the moisture-rich air keeps circulating within and around the equatorial area, creating clouds and creating precipitation, right? And when those air currents move more towards the polar regions, those air currents do not carry moisture because they have already shed their moisture um, as precipitation when it passes um, the latitudes around 30 north and 30 south. So that's actually one reason. Another reason for unequal precipitation is actually a particular geographical area's proximity to water, right? It could be proximity to sea, proximity to a large river, or proximity to larger lakes, right? So, because oceans, large lakes, large rivers are sources of moisture, right? If that's a particular wind pattern, it helps to carry that moisture generated by evaporation, right? And then that kind of moisture carrying winds will actually ascend up with the heated with heating, and then it will ultimately create clouds and results in either rain or snow or any other form of precipitation. And just to highlight this, if you look at some of those oceanic islands, particularly those that occur in the Indian Ocean or South and Central Pacific Ocean, islands in those areas, all of those islands receive very high precipitation, not only because they are located within the tropical areas, but because they are surrounded by oceans, right? So the oceans provide, because of the tropical climate, it's hotter, so there is a concurrent evaporation, continuous evaporation happening from water bodies from the ocean and creating atmospheric moisture, which then form clouds and which then undergoes precipitation. Um, and then if you just switch from oceans to inland environments, if you look at areas like northern Midwest, Great Lakes, areas around Great Lakes areas like northern Great Plains, right? Those areas are rich with large lakes, right? So you might have heard about this lake effect snow, which simply happens because lakes generate so much water vapor, right? And that ultimately acts as a source of water to drive precipitation, right? So if you look at the snowfall records of Great Lake areas like Wisconsin, Minnesota, Iowa, um, they're extremely high, and simply because there's an ample supply of moisture to keep the precipitation cycles happening locally. Another reason for unequal distribution of precipitation is topography, right? So, in simple English, presence or absence of mountains and the orientation of the mountain slopes to the wind direction. This is also a well-known phenomena, and in your ecology you might have learned it. So I'm not going to go into detail. Besides, the graphics over here describes how it happens. So I'm going to actually dumb it down really quickly. Um, so moisture carrying winds blows across the ocean carrying lots of atmospheric moisture, and that wind intercepts the mountain slope, that is the windward slope, the slope of the mountain that faces the wind, right? And once it intercepts, that um, moisture rich air pockets starts rising along the mountain slope, and with the elevation condensation happens. So now this moisture forms clouds, and then the clouds cannot hold water that longer with the elevation, and it creates precipitation. After the precipitation, the dry air currents that deprives of moisture flows across the other slope, right? The slope that does not face the wind, which is called the leeward side, right? And as the wind flows from that side, that particular dry, moisture deprived wind picks up moisture from the leeward surface, right? Or the leeward side of the mountain. So as a result, the windward side of the mountain gets so much precipitation and the leeward side gets dried out. So because of this, you see completely two different types of ecosystems. In the windward side, you get this lush growth of vegetation, right? That could be like certain um, Pacific Northwestern rainforests occur predominantly on the leeward side of the mountains, right? On the windward side, you actually get deserts, arid environments, dry ecosystems. So, and this kind of variation is found all over the Western North America, as well as in um, the Andean mountains of South America. Now, let's take a quick recap on different sources of fresh water. Um, in fact, glaciers, ice, and snow, right, as a freshwater source, accounts for the largest reservoir of fresh water, right? If you read literature, you will find estimations ranging from 80 to 90% of the global freshwater budget exists in these solid forms. Um, so mostly that's found in Antarctica, Greenland, right, and many other parts of the polar regions, including the Arctic, which includes the northernmost latitudes of North America, huge portions of Scandinavia, huge portions of the Siberian landscape, right? And on top of that, in non-polar areas like in mountain tops, right? You also find huge extensions of glaciers and ice and snow. We call them alpine glaciers. Those are the glaciers found on mountain tops. Now, those are important to keep other sources of surface water going, right? Although glaciers, ice, and snow are not readily available for biological needs, they can, through slow melting process, feeds into rivers and streams and lake during spring and summer, and keep water available, particularly in lower altitudes and lower latitudes. So 75% of Colorado River's water supply stems from melting snowpacks and glaciers of the Rocky Mountains. Another example, Lake Argentino is also fed by a particular glacier that's found within the Andean range in Los Glaciers National Park. And then again, there are several examples that I can keep going on. So if you go into tropical areas like in the river Ganges, right, the glaciers in the Himalayan mountains is responsible for providing water for Ganges River, and thus many ecosystems and many human communities relying on that water to sustain their livelihoods. And Ganges, in fact, is the critical water source that provides that supports freshwater water demands as well as electricity generation through hydropower in two countries, in India as well as Bangladesh. And then in Bolivia, there are several municipalities, right? Major municipalities uh, that depends on glacier melt as a source of water and for electricity generation for those municipalities. And in fact, in 2009, this glacier in Bolivia melted completely, which actually resulted in many socio-economical as well as political problems. Similar situation happens in the Italian Alps. The melting glaciers due to climate change, right, have actually resulted in a water crisis across many parts of the world that actually led into political conflicts internally and political turmoils internally. And you can actually read up on these socioeconomic problems, on your own time. But this being a science class, I'm not going to go beyond just mentioning these things. But the point is, when you take decisions in policies, even at local governmental level or national level, environmental conservation, environmental natural resource management is extremely critical. If you don't, it does not stay as an environmental problem; it becomes a political problem. So the incidents I was referring to in Bolivia, the Chacoltaya Glacier made headlines in 2009, 2008 to 2009 period. In fact, the scientific research on what's happening to this glacier can be dated way back. It has been it has been well monitored. The data collection can be dated back to mid 1900s. So as you can see in these photographs, right, by 1940, you are looking at a glacier that actually sized, about um, zero point 0.2 square kilometers in size, and then um, by 1982, right, it actually dwindled by about 50%, right, and even by 1996, um, it actually dwindled again by another 50%, and by 2005, right, it was limited to like a 100th of a square kilometer. You can see like a couple of snow patches, and by the time of 2010, it was just a few tiny snowflakes remaining here and there. So that's kind of, and then I try to read up on scientific reports and publications on this glacier situation right now. I couldn't find any good news to share with you. It's actually even worse. So, um, not only this glacier was this kind of the headwaters for most of the um, drinking water supply in the cities downstream, in the Chakalchaya foothills and lowlands. It was also um, a livelihood for many people by the means of maintaining a ski resort, because this was a like a nice beautiful mountain range, ideal grounds for skiing. So there was several ski resorts, that actually based on which several people had a livelihood. Now all of those ski resorts up to date are closed or malfunctioning, right, because there is no snow for them to ski on. So, and this problem has been recognized by scientific community, but the nobody realized that this would be this much of a problem. It actually became a scientific problem where scientists warned about, was ignored by the global political realm, and which actually led to a uh, a massive socio-economical problem later on. So now, could just the Bolivians have solved this problem themselves? No, melting glacier is actually more of a global problem, so it has to require a global resolution. Climate change is a problem that has to be solved at global scale, not at individual or personal scale.